Thank you. Welcome to Rethink Education, Episode 2. Rethink is our program and series for bringing together some of the best thought leaders and practitioners in the world to talk about how they perform at the ultimate levels. During this series, we get to talk about education, and all of you here. This episode, as we talk about the biology of education, and very seldom do we get to have a world premiere of something. But just to tempt your appetite a little bit, we will get to have one world premiere from an education perspective. We're here from the beautiful little theater in El Segundo, California, at El Segundo High School with faculty and staff. So thank you for inviting us. We're honored to be here on that. My name's Hobie Darling. I'm the co-founder and partner in Liminal Collective. Every day, we get the great honor of working with some of the best performers in the world as they think about what it looks like to perform at their very highest levels. Those are performers across almost every field. That could be science, academia, sports, college sports, professional sports, but all people looking to reimagine what's possible for themselves and for those around them and their teams. Before I go any farther, I do want to say to all of you that are in the audience, both online and here in El Segundo, just a deep thank you from us as we think about over the last 18 months, the heroes that you really all have been with our children and in our communities. So today, we're going to shift from what we get to work with a lot are those athletes and creatives and surgeons and academics to focus on the great performers that you are and what you've done not only over the last 18 months, but in your careers as educators, being those elite performers, working under pressure in high-stakes situations that really matter. What you do every day in your classroom, affecting child by child, classroom by classroom, community by community, truly an up-leveling of what humanity can be. I'm also thrilled to be here today with my co-host, Maddie Mortimer, who is a great performer in her own right, from being a D1 athlete to being an educator in the classroom, to then also moving to being a researcher at MIT and Chan Zuckerberg, to now leading the technology company Logitech's initiative around education and bringing technology that's human-centered into the classroom to improve outcomes. So, Maddie, number one, welcome. But number two, you get to be in a really unique situation in that you're listening to educators every day. You're listening to, one, what are their problems? What are their challenges? How can you help them? Tell us what you're hearing.
Yes, thank you, Hobie, and also thank you to El Segundo High School for having us today. We're so excited to be here, and their educators and educators nationwide for sharing your experiences over this past year. What we're hearing from you is you're striving to implement some of the positive learnings from last year. However, you're feeling the pressure from multiple different angles when it comes to the concept of learning loss recovery. We're hoping today to really dig into learning itself and look at it from a biological level. We hope to leave you with many different actionable strategies that you can start implementing into your classroom today.
It's perfect, and I love that you left with actionable strategies, because in this series, I think there are a lot of times people hear, oh, there's thought leadership and there's research on this, and our goal is to have it so that when everyone walks out of this room, or for the thousands of people that are online, here's something that I can start to do immediately when I get off of this series or when I get back into my classroom or I get back into coaching. So to start that, how at Liminal we work with elite performers is we always start with a model. And we call it our elite performance model that's built up of 10 factors that generally, when optimized, lead to great performances. This is the same model that we use when we are working with those, whether it's naval special warfare, to NBA teams, to NFL teams, to a performer who might be getting ready to go on stage or be on the silver screen. It's the very same as we do it today. So in our first episode, we focused on the cog of spirituality. And what did that mean around education, especially when we thought about meaning and purpose? We had 3 great guests. First, Dr. Andy Walsh. Second, we had Adam Grant from the University of Pennsylvania. And third, we had a special guest and Teacher of the Year finalist, John Arthur. And they really unpacked what it looked like as an educator to bring meaning and purpose, especially in a COVID environment, with the pressures that came along with it. Today, we're going to move on to our next cog and move from spirituality to the physical cog and the physiological cog, and think about something that's dear to, I know, a lot of people on both online and in this crowd is, how do we really think about learning? If we pulled it back and we said, why is so much of we're here learning? And how do we think about optimizing for the people that we teach and for ourselves, how we can both learn at faster rates, how can we recall more, how can we then integrate that information? So we have a great panel of people today, both on the research side as well as on the practical side. The first person that I'm going to bring up is a dear friend. He is also a partner of mine at Liminal Collective. Many of you may know him for having the #1 health and fitness podcast on Spotify. He's also a professor of neuroscience at Stanford University. Please welcome Dr. Andrew Huberman.
Well, delighted to be here and to talk about neuroplasticity. Many of you have probably heard of neuroplasticity. Put simply, neuroplasticity is the nervous system's ability to change in response to experience. When I say the nervous system, I mean the brain, the spinal cord, and all the connections that the brain and spinal cord make with the organs of the body, and that the organs of the body communicate back to the brain and spinal cord. And the reason I say nervous system and not brain is because many forms of learning, including language learning, learning math, etc., include a motor component, movement of the body and the action of the organs and so forth. Today, we're going to talk about the science of neuroplasticity and how is it that this incredible phenomenon of an organ changing itself to get better, how that occurs, right? And the reason I pause is because it is really staggering. You know, your liver, your lungs, your heart, they don't actually rewire themselves to be better. In addition to that, your nervous system is who you are. It really makes up your sense of self, your ability to do anything, past, present, or future. So today we're going to focus on a number of different things related to neuroplasticity. First of all, we're going to define the logic. What is neuroplasticity? Then I'm going to talk about mechanisms, biological mechanisms, and I promise that regardless of your background, I'll make it very accessible. I won't use much specialized language, and if I do use specialized language, I'll be sure to point out exactly what it is that I mean. And then we'll get to the most important part, which of course is the tools, both the testing of tools and the deployment or implementation of the tools. And I'll give to you what I call a plasticity super protocol, which is super because it reflects the research on neuroplasticity over the last 50 years, including some very recent research that's taken place just in the last 2 years that, at least to my knowledge, has not been discussed publicly. And today you're also going to see a first-time implementation of those tools and mechanisms. So mechanisms, then tools, and it is important to understand a little bit about the mechanisms first. Okay, so what is neuroplasticity? Let's just ground ourselves in this discussion. Neuroplasticity, as I mentioned, is the nervous system's amazing ability to rewire itself, to literally change the connections so that you can do new things, forget certain things, learn other things, etc. Sometimes this involves the addition of new neurons, new nerve cells. But despite all the headlines you've read about new neurons are not the primary way by which the nervous system changes and grows. But yet, the nervous system can change tremendously. You can acquire new skills throughout the lifespan. So this is very important to understand. And the way it does that is through a 2-step process that I'll describe. One in which learning is triggered. That's actually what happens in the classroom, on the field, or anytime you're trying to learn something. It's triggered. But the actual rewiring, the reconfiguration of the organ so that it can function better and differently, that occurs during periods of deep sleep and other forms of non-sleep rest, and we'll talk about what those are. Neuroplasticity can be adaptive, meaning it can allow you to do new things that you couldn't do before, which make you feel better, do better, think better, etc. And it can be maladaptive. So neuroplasticity also includes the maladaptive things that happen after a brain injury or things of that sort. Today, we're only going to focus on adaptive plasticity. Okay, but neuroplasticity actually means both things, the rewiring in response to bad events and good events. Neuroplasticity can be passive or it can be active, and this is vitally important. From about the time you're born until about the time that you're 25 years or so, it's not a strict cutoff on your 25th birthday, but about that time, you can learn, any human being can learn passively by mere exposure to information or experiences, or actively by a dedicated focus and pursuit of change. After 25, there's a shift whereby the nervous system, you, all of us, can only really learn through active pursuit of knowledge and change. Now, that's not true for the bad types of changes, the maladaptive changes. Those can happen throughout the lifespan. You don't have to seek those out for them to reshape you. But again, today we're only focusing on active, adaptive plasticity. So what I'm going to talk about today really pertains to organisms, people, throughout the lifespan. But when I say passive plasticity, I want to emphasize what that is, because as you know, children just have to be exposed to an environment in order to change in response to that environment. And this is a slide, which I'll explain in a moment, that explains the incredible precision and detail to which we are all uniquely wired as a consequence of our experience through these passive plasticity mechanisms. This is a slide gleaned from a beautiful paper by Dan Adams and Jonathan Horton at University of California, San Francisco. It is grounded in the basic work of David Huberman and Torsten Wiesel, who won a Nobel Prize in 1981 for discovering these types of mechanisms. What you're looking at, that brown stuff with the spiderweb looking image in the middle, is actually a piece of the brain from a human post-mortem that's been flattened and put down onto a slide and imaged under a microscope. And the brown label that you see there represents neurons, nerve cells, many millions of them that were metabolically active. And the darker regions are areas that were more metabolically active. So this is sort of a map of the experience of this individual. What is that spiderweb looking configuration spanning out across the cortex? What it is actually a reflection, a fingerprint, if you will, of the shadows that were cast by the blood vessels in that individual's eye. So what does that mean? Well, we all have eyes, most of us anyway, have eyes, and we have blood vessels that obscure the light falling onto our so-called retina that converts light information into neural signals. So we are all walking around all day in a series of spiderweb shadows, but we don't detect those shadows because the brain has this incredible compensatory mechanism we call neuroplasticity. During development, in a purely passive way, the brain has rewired itself such that on the opposite side of the brain, the more active regions are the ones that reflect the deprived input from the world. What does this mean? It means that because you are blind through many regions of one of your eyes, the opposite side of your brain has compensated for it by filling in those areas, so you see the world as a coherent whole. Why is this important? Well, it emphasizes two important things. First of all, that this didn't require any effort on your part or on this person's part. Your brain is uniquely shaped. There is a fingerprint of your unique experience, of your retinal vasculature, the blood vessels, but also everything that you experience from 0 until 25. You're walking around with a map of that experience. And while here we're talking about a visual experience, that's also true for every emotional and cognitive experience and motor experience you ever had, which is remarkable. And it illustrates the most important point, which is that your brain is a map of your prior experience. Now, that's passive plasticity. Active plasticity was discovered by Mike Merzenich, also at UCSF, in the 90s and in 2000s. Up until then, it was thought that the adult brain could not change, that it couldn't really learn or change that much. I'll make this slide simple in a moment. What this slide shows is 3 panels of electrical recording sites from the auditory region of the brain in subjects that were either passively exposed to a tone of, say, 2.5 kilohertz. If that doesn't mean anything to you, don't worry about it. Just a tone of a particular frequency, just passively listening to it. These are adult subjects, and the brain just doesn't change. There's no remapping whatsoever. However, if the subject was required to listen to that tone in order to glean a reward of some sort, or to distinguish that tone from another tone which was similar but not exactly the same, then what happens is in the middle panel, those darker regions represent the expanded representations of that tone. In other words, if you pay attention to something, your brain will rewire, in response to that experience as an adult. And this seems almost obvious to us now, but until the early 90s and 2000s, this was not considered to be the case. So the brain rewires as an adult, and that third panel simply reflects the fact that if those tones are played in the room and you're taught to pay attention to something totally different, like the sensation of touch, then it doesn't have the same impact. So it's not just that you are attending, it is that you are attending to a specific thing, and it is that thing that rewires your brain in that very specific way, which lays down the first requirement for learning of any kind, which is that there has to be focus. And as a prerequisite to focus, there has to be alertness. If you are not alert, you cannot be focused. And without alertness and focus, you cannot rewire the brain as an adult. Today, we'll talk about ways to access alertness and focus in very specific and simple ways. There's a neurochemical basis for this thing that we call focus, put in air quotes by me, because I don't like terms that don't have an operational definition. When people say focus, say, well, what does that mean? Well, there are many elements of focus. There's visual focus, there's active listening, there's auditory focus, there's focusing on touch, there's focusing on our internal state, what we call interoception. So what is focus? Well, the reason this adult plasticity can happen at all is because you have a cluster of neurons deep in the base of your brain called nucleus basalis. You don't need to know the name, but nucleus basalis houses neurons that release a molecule called acetylcholine. And when acetylcholine is released, it is a gate on neuroplasticity, and focus and acetylcholine work together like a gang to ensure that a plasticity can happen. And this simple slide, what might look complex, is a color-coded representation of auditory sounds in the cortex of different frequencies. So low tones and high frequency tones, colored from reds to blues and to magenta and so on. In this particular experiment, Merzenich and colleagues paired the playing of a particular tone, much like in the previous experiment, but paired it with stimulation of nucleus basalis. And in a matter of seconds, that allowed massive regions of the auditory brain to rewire just specifically to that tone. This reflects the focus and the neurochemical signature of focus in the adult brain. What does this mean? This means that you have chemicals in your brain that allow you to focus and that open the gates to plasticity. And we'll talk about how to access those chemicals through purely behavioral means in a few slides. Okay, so that's the triggering of neuroplasticity, put into a couple summary slides or so. It's a vast literature, but just very briefly covered. But as I mentioned before, the actual rewiring of neural connections occurs during sleep and sleep-like states. There are now thousands of studies in quality journals from excellent groups around the world illustrating this. What happens during sleep is worth considering, however. During sleep, there's a reactivation of the same neuronal sequences. Neurons are just nerve cells. They fire with electrical activity. And it's a replay, much like the replay of the keys on a piano during sleep, forward and backward and at very high speed. That's why you learn in sleep. You are actually grabbing more repetitions of the activity, what I call neural repetitions as opposed to physical repetitions. So in sleep, you are rehearsing and you are rewiring the brain so that what was once hard or impossible or had to be carried out with an intense amount of focus becomes reflexive. There are a number of titles here of different papers that emphasize this point, but the reason I picked these is they emphasize that visual discrimination, skill learning, developmental plasticity all require deep sleep. Now, excitingly, neuroplasticity has also been shown to occur during what I call NSDR, or non-sleep deep rest. I coined this term NSDR because I felt it was important to put an umbrella term over things like naps, yoga nidra, hypnosis, and meditation, which vary tremendously in terms of protocol, but are all anchored to the same common point of bringing people into a state of relaxation and typically limiting their amount of focus on any one thing. There are certainly forms of meditation and hypnosis that involve hyperfocus, but most of the time, naps, meditation of the sort that we're going to describe that can enhance learning, involve turning off thinking to the extent that one can. relaxing to the extent that one can. And what's beautiful is that in just the last 2 years, there have been papers published in excellent journals like Cell Reports, a Cell Press journal, very stringent peer-reviewed journal, showing that during shallow naps or just resting after learning for 20 minutes or so, there's a rapid replay. These neural repetitions occur just like they do in sleep. And that has been linked directly to enhanced speed of learning and depth of learning. So this doesn't just mean naps, and this doesn't validate napping in the classroom, which I confess I did a little more than I should have when I was in high school, but it does validate the use of naps. But I'll also talk about other protocols that you can use in the classroom that don't involve students sleeping necessarily. Turns out that post-training meditation of a particular kind can also promote motor memory consolidation. I'll just show you these data. This is a little bit of a busy slide, but the point is this. A morning training done at about 8 a.m. followed some hours later by a 30-minute meditation of the so-called yoga nidra sort, which involves just lying there passively. There are no down dogs or up dogs or any kind of active process, just listening to a script. I'll point you to some of these references in a few minutes. And then later testing of that material showed a dramatic and significant reduction in reaction times for this motor task. That's a good thing, as well as speed and consolidation of learning of other sorts as well. So this is a intervention to enhance learning that mimics sleep in certain ways. And we know this based on brain recordings of what happens during things like yoga nidra. And then excitingly, just this last year, work published also in Cell Reports showed that consolidation of human skill learning is linked to this activity replay that occurs while people are trying to learn if they take very brief 10-second breaks frequently throughout that learning. So what does this look like? You'll see an example of this in a few minutes in the classroom, but what this involves is actively teaching and learning between students and teacher, but then randomly, it could be a tone goes off or this teacher says, let's stop 10 seconds, close your eyes, just stop doing whatever it is you're doing. Doing that randomly throughout the learning bout greatly enhances the speed and depth of learning. Why? Well, the beauty of this study is that they actually recorded from the hippocampus and the neocortex, regions of the brain involved in memory consolidation and learning, and showed that just like in deep sleep, during those brief pauses, there's a rapid replay back and forth in forward and reverse direction at anywhere from 10 to 20 times the speed. So students are getting more repetitions per unit time overall through these 10-second gap effects or gap learning effects. Gap effects and gap learning effects have been known about for a very long time, but their underlying mechanistic basis, was not known. And it's remarkable to me how closely this mimics what happens during actual deep sleep. The graph or the plots that you see there to the right of the slide just simply show that this rest occurring during learning, what they call inter-practice rest, had a dramatic impact on this repetition, these neural repetitions, as compared to pre-training rest or post-training rest. So now let's talk about applying the science of neuroplasticity to enhance the depth and speed of learning, right? I've thrown at you a bunch of information about the mechanisms of neuroplasticity as they stand now in 2021. No doubt these will change and evolve and expand, but whereas the last 20 years or so has seen a lot of discoveries about things like brain-derived neurotrophic factor, about the addition of new neurons through exercise, about the value and importance of sleep. It's only now, 2021, that we really understand at a mechanistic basis why things like sleep and non-sleep deep rest, shallow naps, brief 10-second pauses in the middle of learning, why that should increase plasticity at all. And it's because you're just grabbing more and more repetitions and you're allowing time for those neural circuits to reorder themselves, which is the basis of learning. So is there a neuroplasticity super protocol? Indeed, there is. There is, because what we can do is we can grab our arms around the total of information that's known about neuroplasticity, and we can push that through a funnel of what's required in the classroom, what's feasible in the classroom, what's reasonable to think about in 2021 as a way to accelerate learning using these principles of neuroplasticity. And I'm delighted also to say that it is only now in 2021 that we can point to studies not just in model organisms, mice and non-human primates and rats, but most everything I talked about today was done in humans and has been demonstrated in humans, which is wonderful to be able to say that. There are a few areas of neuroscience and indeed in biology for which we can say that the information in all these papers on model organisms can be directly applied now in humans and has been applied in peer-reviewed studies, and indeed it has. And so we can talk about a plasticity super protocol. I do want to point out that, of course, this super protocol is not written in stone. This was not handed down to us, okay? We're talking about this and creating it as an active living protocol that will be continually updated as new research emerges, of course. I just briefly want to mention before I describe the protocol that any change to our nervous system can involve behavioral tools, so things that you do and things that you avoid doing, do's and don'ts. It can involve pharmacology, and it can involve brain-machine interface. And nowadays, you'll hear a lot and see a lot about fantasy pharmacology, limitless pills, nootropics, things that can enhance alertness and focus. And indeed, there are many clinically useful tools that involve pharmacology, for instance, for the treatment of attention deficit hyperactivity disorder, whose main role is to increase the neurochemical substrates by which the brain creates alertness and focus. Now, outside the clinical realm, however, behavioral protocols are extremely important. And indeed, anytime you involve pharmacology, behavioral protocols are still important and perhaps the most important thing. As a clinician and a respected colleague of mine likes to say, better living through chemistry still requires better living. There's no pill by which you can induce neuroplasticity. There is no plant by which you can induce neuroplasticity that is directed toward a goal. Only behaviors and protocols can direct plasticity toward a particular goal. Rewiring the brain is not the goal. Rewiring the brain in specific ways that are adaptive is the goal, and that requires behavioral tools. So we're going to focus on those. Brain-machine interface is a very exciting area of emerging research. Right now, it is limited mainly to the clinical realm. So things like Neuralink, neuroprosthetics, and things of that sort, very exciting areas. But right now, we're thinking about classroom, non-clinical settings, at least for sake of this discussion. So here is the protocol that grabs around the total of research and that one could incorporate into the classroom. And I want to emphasize, you don't need to incorporate all these tools, but a few of them are non-negotiable. First of all, without alertness, there is no learning whatsoever. You cannot learn in your sleep. Years ago, it was thought you could just passively listen to information in your sleep. And while there is some evidence that if you listen to information that you heard earlier that day in sleep, it can enhance learning. There's no way to learn by osmosis like the Garfield cartoon of Garfield holding the book to his forehead. It's been tried many times, and indeed it does not work. You have to be focused. Alertness is a prerequisite to focus. These two things work together, and we can combine them in a sort of conceptual mathematical formula to give us the ever-elusive motivated state or motivation. So much has been made of motivation. Indeed, it has a neurochemical substrate called dopamine, is the molecule of motivation, not pleasure, by the way. Getting alert involves getting focused, getting alert, and that combined is what we call being motivated. Ways to do that. Well, without going into the data here, there are interesting and I think important data showing that listening to white noise or a white noise background can shift certain aspects of the circuitry in the brain related to alertness. These circuitries have names that, if you would like to look them up, have to do with the reticular activating system and the thalamus that raise our overall level of alertness by playing white noise at a tolerable volume in the background or in headphones prior to learning or on entry to a bout of triggering learning. There are other ways to do this too. For sighted individuals, for instance, most of the brain's ability to focus follows visual focus. Most people don't realize this, but these two little bits that we call eyes are actually the only two pieces of your brain, of your central nervous system, that reside outside of the cranial vault. And they are there for a reason. They are there to detect whether or not it's night or day in order to raise levels of alertness or to promote sleepiness. As well, they are outside your skull so that you can detect things at a distance. We call that vision, although you can do that by hearing as well. The fact of the matter is that where you look and your ability to focus actually creates a state of heightened focus and alertness in the brain. And so a very simple, essentially zero-cost tool is if you don't have access to white noise, or even if you do, if you were to say draw a visual target or have your students draw a visual target at the distance from which they are going to be doing their learning and their work in the subsequent lesson plan, and have them focus on that for anywhere from 10 to 60 seconds while reducing blinks. If they have to blink, they'll blink. People vary in terms of how dry their eyes are. Blinks actually reset your perception of time. So what does this look like? This involves, okay, we're gonna do a lesson. You're gonna sit down, you're gonna focus on a visual target at about the distance of the thing that you're going to be focusing on for 10 to 60 seconds. This brings online the very circuits that are involved in elevated levels of focus and alertness, these sort of elusive things that both adults and kids chase with things like coffee, caffeine, and other kind of methods, but indeed you all have the ability to focus. If you've ever been suddenly stressed about something, you know that you have the ability to focus within a millisecond. Those circuits exist within you, and visual focus is the primary way by which you anchor your cognitive focus. For those who are not sighted, so-called low vision or no vision folks, they learn to do this, very well through their auditory system by coning their attention to particular locations. Numbers 1 and 2 on that slide are absolutely non-negotiable for adult learning and can enhance childhood learning to a tremendous degree. Next is to generate repetitions. It's very clear from the neuroplasticity and learning literature that you want to generate as many repetitions of what you're trying to learn as you safely can. What do I mean by safely can? Well, running hurdles and learning to run hurdles is very different than playing scales of music. The safety margins vary there, but of course, if you play your scales too fast, you are not going to be able to generate them at all. So there's always a threshold there. But the idea is to say, okay, we have a lesson plan that's going to last, let's say, an hour. Get alert, get focused, devote some time to that. Understand that that's a process, not a switch. Getting alert and focus is a biological process that takes time. I give you some tools to enhance that. Then to generate as many repetitions as you possibly can per unit time. Maybe you say, for the next 10 minutes, we're just going to generate as many repetitions as we can. And the usual question is, well, then I'm going to make more errors. And indeed, that's wonderful. Expect and embrace errors. We hear so much about how wonderful it is to fail in life. Nobody likes to fail in life. But on a short time scale, errors generate an increase in alertness and focus. There's a well-described phenomenon by which an error in an attempt to complete something creates heightened levels of activity in the so-called prefrontal cortex and its related networks in the brain. In an essence, errors increase your ability to focus. And that makes perfect sense. If you were to, say, throw darts and you hit a bullseye, you might be happy about that. But you actually, on the subsequent attempt to throw that dart, your level of attention is actually reduced compared to if you had missed or even had gotten close, because your brain is actually trying to figure out where the gap is in circuitry in your brain and in the motor command. And so errors actually generate focus. So they're wonderful. Generate as many repetitions as you can while expecting and embracing errors as a mechanism by which to sharpen focus by enhancing this prefrontal activation. Fifth, randomly insert those micro rest intervals. I already showed you the data for why that's useful. How many? Well, random is random. 10 seconds to 30 seconds is ideal for each one. How many depends on how long the lesson plan is. And so I wouldn't put too much effort into figuring out the optimal ratio. Don't obsess over optimal ratios, just introduce them somewhat at random throughout the lesson plan. Again, those just involve people, children, adults, stopping, closing their eyes, not doing much of anything, certainly not generating any kind of motor command. These equate to, as I described before, more neural repetitions, as paradoxical as it seems, but this is also what's happening during sleep. Use random intermittent reward. Excuse me, there's an entire lecture that could be done about reward schedules and dopamine in the brain, but we can just borrow from the casinos and the gambling community. What keeps people playing is random intermittent reward. When there's an expected reward, it diminishes the capacity for focus, for attention, and for learning. Random reward is what works, and sometimes the best reward is no reward at all. If you want to keep the dopamine system potent, yours and that of your students, sometimes you just end the lesson and just let them leave. If they come to expect the praise, the pat, the reward, it will undermine their learning. And I realize that this wicks out into a whole business of self-esteem, et cetera. But if we can link somehow, and I think we can, self-esteem to one's expectation of dopamine, I encourage you to look up something called dopamine reward prediction error. The more regularly that you expect reward, the more potent and extreme that reward has to be in order to remain effective at generating effort. Okay, so remove reward, and this includes removing self-rewards. You did a good job that day, great. Roll into the next lesson plan. Every once in a while, reward yourself, of course, but don't work for reward. And this gets right down to fundamental issues of intrinsic and extrinsic motivation that tie back to important studies done in psychology over many decades. Limit learning. Trigger sessions, these highly focused alert trigger sessions, are taxing by definition. There's energy that we think of in terms of caloric energy. The brain is the major source of caloric consumption in the body in terms of organs. And it's hard work. It's hard work to focus. It's not supposed to feel necessarily good. There's an underlying state of anxiety sometimes, and that is because the molecules of alertness, such as adrenaline, also called epinephrine, involve a bias toward moving, and a bias toward moving is what we call agitation. Those are healthy forms of alertness. 90 minutes or less total, and then ideally you incorporate some sort of 5, or ideally it would be a 10 to 30 minute non-sleep deep rest, or even a nap if it's feasible in the context of your learning environment. And then we'll be to incorporate 10 to 30 minute NSDR, non-sleep deep rest, post-learning trigger sessions. And remember, these don't have to come immediately after the lesson plan. They can be some hours later. But much like nap time when we were really little kids, this turns out to be a very useful thing. And I'll just mention that many of my colleagues at Stanford, who are incredibly high performing, incorporate naps as a daily component of their work for sake of enhancing plasticity and also, of course, alertness afterwards. Whether or not you should nap and for how long, there's a simple equation that we can glean from the sleep science literature. If naps interfere with your ability to sleep at night, don't do them. Do an NSDR, non-sleep deep rest protocol that doesn't involve napping. If you can nap for 90 minutes or less, even a 10-minute nap has been shown to be beneficial for enhancing different aspects of learning. There's some resources here. Reverie.com, REVERI.com is an excellent resource. It's a app that's zero cost for Android and Apple that was developed by my colleague, Dr. David Spiegel. He's a medical doctor and our associate chair of psychiatry at Stanford. It involves self-hypnosis protocols for enhancing capacity to relax, to focus, as well as other scripts, as we call them, hypnosis scripts. These are not the hypnosis scripts that are going to make you do anything outrageous. You're in total control. There's excellent data, both clinical and experimental data, to support what's in Reverie, and it's all on that website. So quality peer-reviewed research. Non-sleep deep rest at Made For on YouTube, and then Yoga Nidra scripts come in a variety of voices and durations. You can look these up on YouTube, easily define those. And then last but certainly not least, you want to maximize the quality and optimal duration, which will vary for everybody, of sleep that night and the next, because that's when much of learning, aka neuroplasticity, takes place. If you'd like to get better at sleeping and understand various tools that range from behavioral to brain-machine interface, but certainly mainly focused on behavioral tools, my podcast, the Huberman Lab podcast, the second episode is called, I believe it's Master Your Sleep, and essentially gives you more tools than you could ever hope to implement. Maybe just listening to it will make you fall asleep. Doesn't matter to me. The tools in there and or listening to it should help you sleep, which is vital to this learning process. So I'm going to close with that. Because that slide will be on record on the internet, you'll be able to get that information. I've really tried to emphasize the mechanisms first and then give you a sense of the tools, and now you ought to know why those tools are listed out in the order that they are. This is a unique opportunity today because typically I'll talk about mechanisms, I'll talk about tools, and I'll shout into the tunnel of the internet, which is a podcast or an Instagram account or something like that. But we've had this really unique and special opportunity thanks to Logitech and my introduction to the incredible Ben Eady, who has taken these tools or a subset of them and implemented them in the classroom for sake of teaching music to his students. This, as far as I know, is the first ever practical implementation of the modern neuroscience of neuroplasticity in the classroom. And it is by no means exhaustive of all the things that could be done. It's one context and one example, but it is a tremendous example where somebody, Ben, took these tools, learned the science, took the tools, and then implemented them in the classroom. And I really want to tip my hat to that and to his students for embarking on that journey, because science that's vaulted in journals or that you just listen to somebody talk about, me or anyone else on the internet, that's helpful, it's useful. Knowledge of knowledge is certainly useful, but the practical implementation of these tools is really what's vital, and what I believe and Ben believes and Logitech believes will lead to enhanced learning for sake of all things, music learning and other. So we'd love to show you an example of this in the classroom, and so we'll transition to that now. Thank you very much.
My name is Ben Eady. I'm a professional musician and a music educator. I came to realize that there was a very inspiring and compelling world to incorporating human development and science as well as compassion into a profession. Most music teachers, I would say, would probably agree with this, that the learning doesn't happen in the classroom. The learning happens when the student is on their own. This is supported by Dr. Huberman's research, which is that when you're on your own or when you're outside of the room, that's the time for you to take stock of what you learned and for you to replay it, not necessarily just with the instrument, but also internally. Today, we're going to be talking a little bit about the blues. I love the blues because it's a really cool starting point for popular music. When I was greeting them and we were doing our introductions, I had some white noise, essentially changing the atmosphere so that they know, okay, the next thing we're going to be doing is we're going to be learning, we're going to be listening and taking in some information.
The white noise, it did make me feel a little concentrated, and I was thinking about, what would happen next, my tone, and, just everything about playing.
When the conductor breathes in, that's the cue for you to be ready. Cool. And when I breathe, you should breathe with me too. My aim is, I hate conducting, I'll be honest with you. And the best kind of band is the one that talks to itself. This time, everybody breathe with me. I think we're just about ready.
The breathing exercises helped. I was able to focus with them. I was able to work on the timing, all that kind of stuff.
It's really cool, like the different exercises he uses. I think the breathing really helped to unify the group.
When I have students working on something, I'll have them repeat it, and then I'll say, all right, stop, and then keep going. In those moments, there's nothing else to do. It's a little bit jarring, and so the student really dives within themselves and finds, so what is it that I just did? And what is it that I'm going to do next? And when we start again, there appears to be this renewed intensity on getting whatever it is we're learning or whatever technique it is we're trying to do. So ready? 1, 2, ready, go. Awesome. I want you to take a moment, think about the sound of the scale. And I want you to fix it in your mind, especially the sound of that resolution not happening. I want you to fix it in your mind.
The 10-second pauses helped me to learn, because I feel like a lot of the time I'll learn something or I'll hear something and I'll just rush to play it immediately. And I feel like sometimes that doesn't give me enough time to register it. But when I stop and I thought about it, it was much easier to imagine and hear in my head. So when I was actually playing it with everybody else, I could play it a lot better because I could hear it in my head.
The time to pause and think for myself, it actually boosted my confidence more when he was able to give us time to pause and think. It really let me think back and remember, okay, I'm capable and I'm ready to do this. Being able to have that mindset while actually playing with everybody else really helps calm down the situation.
There's an old jazz adage that you might have heard me mention to the students where they were saying that the right note is just a half step away.
It makes you nervous knowing that you have to play something in front of other people, knowing that you could mess up. No
worries.
Is this a B7?
Yeah.
Whenever I made a mistake, he wouldn't be like, stop, we gotta restart because Cooper messed up. He would just like point at the board to like show me where we were. And it was just a really supportive environment where I felt like if I made a mistake, it wasn't a big deal.
Once you've played it a few dozen times, then we can start incorporating new elements that allow you to be creative. Like, you've got the form, now I want you to change the rhythm. Or we know how to use this scale, so maybe now you can choose some different notes. After that, I would ask them questions every so often, just so that they, in answering those questions, could make some realizations about themselves. F sharp, and then G open. So can you play all of those one after the other?
Maybe.
I agree with you. So let me give you a couple of aids here.
When you reflect on the way you play, you'll normally see more of the mistakes. And normally, when you play again, you'll notice them more. So you'll improvise and redo it in a better way.
Do folks feel comfortable to try some things out?
Yes.
Yeah.
That's the spirit. We're gonna try, we're gonna make some mistakes, and that's gonna be okay. So get ready. A 1, a 2, a 1, 2, ready. Very nice. Now we're gonna add some more elements to it. I knew that the blues would be a really good choice because it's a way for youngsters to form this community without necessarily knowing each other and be able to engage in the different parts of music that I think are really valuable to them. I believe that music teaches discipline, it teaches focus, it teaches those things that are an important part of living in a society that is moving forward. There are ways that you can essentially like hack your own brain and make yourself a super learner. Thank y'all.
I mean, so cool listening to that. Number one, first time getting to be done on a neuroscience protocol, having Mr. Edie here to talk about it a little bit. Before we hop in, we will be able to do some Q&A. We'll probably take a couple questions from the audience. So if you have things you're interested in asking, start to think about those. Similarly, if you're on the online audience, put those questions in, and we'll also try to get to a couple of those questions as well. So just to kick it off, you got to do sort of this first time neuroscience protocol. Just tell us what worked for you. When you were, if you're looking out to this crowd and looking out to thousands of educators and coaches, what would you tell them? This really worked for me. I'd give it a try.
Yeah, definitely. One of the awesome things I think about this protocol is that one, being based in science as well as being as well as incorporating human development, it works for young people. It's something that they're ready for and something that they naturally adapted for. The thing that worked for me the best, I think, was incorporating those pauses, because I think that in music, a lot of what students struggle with is exactly what Cooper was describing in the video, rushing ahead or focusing on, here's how I move my fingers, or here's the thing I'm expected to do, rather than understanding it on a deeper level. And having those pauses available to reflect for a little while allowed students to internalize, so that for a style of music like jazz or the blues, where eventually improvisation or the ability to like divergently recreate or compose new material is important, they're able to do that because they've got a strong grasp of the material.
And so even just added on that, Dr. Huberman, I mean, you put the protocol together, saw Mr. Edie do it for the first time. What are the things as you watched it in practice versus thinking about it from research? What were you thinking about of, gosh, I'd like to see more of this, or how could this work in a classroom that you'd even bring even more?
Well, first of all, it was positively surprised by how willing the students were to incorporate it. I think that's great. You know, an experiment that leads to a manuscript or paper is so very different than the classroom, because when people enroll in an experiment, they come to my lab, they want to be there to be experimented on. And students in the classroom, if they are going to use tools, those tools have to be able to be incorporated in a way that doesn't feel like a departure from the lesson. So I was delighted. I mean, I think that when students are, especially with music learning, when they're, or in any kind of motor learning, when they're performing something with their hands and they're moving their body, this idea of pausing to reinforce the organ, the nervous system, to take in that information and digest it is really terrific. And so I don't have any immediate suggestions. I think that I would love to see more people doing this sort of thing in a variety of contexts and to give feedback to the scientific community. We've already started that dialogue, Ben and I, and it's really a matter of putting those gap effects and the alertness tools into action.
I want to come back to the protocol quickly. So the first ones that were up there, essentially getting to motivation. I think we see that across the spectrum of things around, whether it's I want to learn, or in various other ways. When you think about that motivation piece, what are a couple other things that a teacher could put into practice tomorrow when they think about pulling that together that you might recommend? And then I'll tee the same thing up, for what you think about that, Mr. Eady and Maddie, what you're seeing as well as an educator.
Well, motivation has a number of different components that can be viewed through the lens of neuroscience at the level of behavior, et cetera. But I think we can all agree that when any of us, a student or otherwise, is very excited or curious about something or really wants to do something, motivation comes easy. It's almost hard to separate motivation from excited, in fact. But if we dissect that a little bit further, we realize that what we're really talking about there is this alert and focus state. And the combination of alertness and focus. And so for many students and many teachers, the challenge is going to be how to bring on board people who are not super excited or curious about that particular thing, or that they have a lot of anxiety of that type of particular learning. And there, the key is to really emphasize to the students and to oneself that alertness is the gate to focus. And alertness can come about through excitement, curiosity, and desire. But alertness also comes about through action. Action generates the release of molecules like epinephrine in the brain, which is adrenaline in the body. Those are actually the same thing, just called different things to confuse us all. And actually doing things increases our level of alertness, which then allows us to access states of focus. In other words, it's very hard to go from 0 to 60 mentally, unless we are very excited or very stressed. And so the key is to get people into some form of action and then to ride that action to a state of heightened focus. And I think I like to think that would help bring on board various students who aren't intrinsically excited about a particular activity. And for the ones that are, to be able to harness that excitement even to a further extent.
So let's dive down. Let's put you on the spot. You're the neuroscience, but I know you're also always learning. Something you come in, you need to learn, but you're maybe not excited about it. What's the Dr. Huberman neuroscience tool here?
How do I scruff myself into learning?
What do we do?
Yeah.
Let's put it into action here.
Yeah, well, I always say it's very hard to control the mind with the mind, that some people can do it, but it's a tricky loop that we can get into. And then we start thinking about underlying reasons and why we don't want to be there and what was happened to us, and it's a rabbit hole that can take up the whole hour. And so rather, I like to use the body to control the mind. And so one powerful tool that my lab has worked on and other labs have worked on based on purely respiration, breathing, is as simple and perhaps even as silly as it sounds, 15 very deep inhales followed by quick exhales. So we'll deploy quite a lot of adrenaline in your system. Even on the third breath, you're going to feel a little warm, maybe a little agitated. Some people might not like that. But then I will often do the visual target exercise. I also we put blinders on horses to keep them focused, and I put blinders on myself. I will airplane mode my phone. I'll turn off the Wi-Fi. But even in the presence of a lot of distractions, generating alertness within the body by deploying adrenaline mimics all the neural pathways that generate alertness. And then I force myself to focus. And then I generally find, just by taking control of my breathing, I've already passed a few of the key wickets of self-control. So I've sort of jokingly referred to scruffing myself, but I've scruffed myself into an action that's directing me down a path that's in the direction that I want to go.
Got it. All right. So we're here to hear from exactly Dr. Huberman, his trick. Mr. Eady, in the classroom, how do you get kids motivated?
Wonderful. One thing that I love about the music classroom is it's one of those places where you give students these devices to make noise and you tell them not to for certain periods of time. And you're correct, the different levels of energy and focus, they vary from student to student. One thing that I've found has been very effective when working with classes of 40, 70 or more students is leveraging your childhood. I think that the most important aspect that a teacher needs to be in resonance with their students in is being able to let the student know that you're also a person. You're not just demanding that they do work or expecting products. And what I find is that in keeping with Dr. Huberman's research, a youngster's focus is often very closely linked with their relationship with their teacher. So students are interested in your life. So I was telling the folks earlier about one of the easiest ways to get a whole orchestra of students to be quiet is just pausing for a moment and saying, you know what, I want to tell you a story about college. And everybody will listen. And the next downbeat from there will be excellent. They'll be together because they've just gotten excited by connecting with their teacher for a quick moment.
I love it. So I actually want to shift this a little bit then to you, Maddie, because like both of these answers have been very human tool oriented, very human storytelling oriented. You have a little bit of a different job, which is how do I think about the future, help educators and students be their best, but also bring in technology.
Yes.
So how do you start to think about the technology aspect of this?
Yeah, definitely. So I think an amazing way that tech can be an enabler in the classroom is offering students different ways to express their knowledge. When we talk about motivation, there's a lot of research out there that shows when students have choice and more autonomy over their learning, they feel more engaged, motivated, they exert a lot more effort. So whether it's as simple as they're typing an assignment, creating a concept map, or having different pods where they can connect with their peers in a hybrid environment, do individual work, having that choice aspect can be so powerful.
So I think the other one that we keep just hearing more and more about is sleep, sleep, sleep. And you ended with it. You also put us to Huberman Lab podcast number 2. If you could give us the 30-second rundown of, again, you want to sleep better tonight, you want to help your students sleep better tonight, give us the quick hit.
Okay, I would say if I'm limited to 30 seconds, which it sounds like I am.
That really means I'm giving you 45 because I know you are a professor.
Toby knows me well. You know, the most fundamental way that our brain and body know when to be sleepy and when to be awake is by when we view sunlight. And for those that are low vision or no vision, this is still often important, and the mechanisms are often still there. So I will say it again and again that viewing sunlight for 10 to 30 minutes, first thing in the mornings, eyeglasses and contacts are fine, even if they have UV filters, but sunglasses off, hat brims off, unless you have a retinal sensitivity to light or some sensitivity to light, get sunlight in your eyes early in the day. This cannot be done effectively through a window, despite claims to the contrary. Do that again in the evening before the sun goes down. If you wake up before the sun comes out and you want to be awake, flip on as many artificial lights as you like. And then the other one is to, as much as possible, avoid bright lights of all colors, whether or not you're wearing blue blockers or not, doesn't matter. From between the hours of about 10 p.m. and 4 a.m., only use as much light as you need to safely navigate your environment. Shift workers and first responders, we have an episode of my podcast on shift work that's particular to that group, and thank you, shift workers and first responders. But for the most people who are sleeping typical hours, who are not nocturnal, that morning and afternoon sunlight viewing and avoiding bright lights between 10 p.m. and 4 a.m. will make a major shift, not just in your sleep, but in the secretion of stress hormones like cortisol that are correlated with all sorts of positive mental health outcomes.
All right, so just to add on to that, so we should be starting to think about in the evening, reducing lights about what time?
Well, it's going to depend by time of year and where you are on the planet. But in general, you sort of know your natural bedtime by virtue of an interesting fact, which is the hour before your natural bedtime, you're going to experience a big spike in alertness. A lot of people don't know this. They get sleep anxiety because they think it's 9 o'clock and they're wide awake. Well, that's because there's this brief spike that we think is due to promoting your preparation for a sleep environment, which you can imagine through our evolutionary history was important. But in any case, the idea would be to view some afternoon light when the sun is low in the sky. So low solar angle sunlight has a particular set of qualities that stimulates the cells in the eye, that stimulate the cells in your body's clock that are optimal. So I don't want people to get too neurotic about exactly when, but 10 to 30 minutes in the morning, less if it's really bright out and there are no clouds, more time, so 30 minutes if it's really cloudy or overcast, even if you're in the UK and it's really dark. So there's always, unless you're living in a cave, there's sunlight to be grabbed and you want to grab that sunlight.
All right. Well, let's start to turn it to our online audience. I know we have a big audience. First question that comes up is, how can these techniques apply when doing school online? Let's see. Let's first maybe put that to Dr. Andrew, how we can think about it from neuroscience, and then Maddie, from a technology perspective, maybe you can give some insight there as well. How does some of this switch when we're now online?
Yeah, so as we've all learned in the last couple of years with the major shift to Zoom and online interactions, when you view, I drew that target earlier, but when you view things in a small box, you are harnessing your attention to that small box. So that's actually conducive to gaining focus, right? You don't have distractions in the classroom unless you see a bunch of heads moving around and people moving around in the Zoom classroom. So to the extent that you can limit your visual environment, that's great. Also, looking at yourself is terrible. This is the first time in human history that we've seen images of ourselves staring back at us as we're speaking. This is engaging other elements of brain circuitry that are really important. We actually have dedicated brain areas for faces, and our face in particular, just like we cancel out our voices. There's a whole process there. So what I would encourage people to do is try and limit the visual environment as much as possible. Trust that your students are still going to be working on what they're supposed to be working on. If they close out their video, I think we need to trust them, and people like to be trusted. The other one is something that Ben's story about telling story is important, and it allows me to just briefly mention a new study that was published in Cell Reports 2 weeks ago, which showed that when people listen to a story, even if they are in different locations, aka online learning, their heart rates and breathing rhythms synchronize. So their physiology synchronizes to the story, even if they are in independent locations. And this is a really important finding, and it actually explains much of what Ben was referring to earlier. The power of story includes the content of the story, but it also creates a physiological coherence among the group. So I think that online learning is a perfect environment with which to do that. So maybe you start with a story or introduce a story the way Ben described, and then you get into the lesson plan.
Maddie, give us the technologist point of view here. What's the trick to online learning? How can we all be better tomorrow?
Yeah, and building upon that, I'd say firstly, empowering students with a lot of this knowledge, how the tech affects them, how being online all day can affect them, and giving them the tools to best cope with all of this new environment, especially now since it's very much in flux. There's still a hybrid environment that exists. And secondly, I'd say in terms of just overall education on tech, we're at a stage now where we're very much focused on concepts like digital citizenship and how to behave online. But beyond that, just how to best use tech in an effective way, both in the classroom and beyond. Building upon what Dr. Huberman was talking about from a sleep perspective, how blue light affects students the night before a big exam, all of those types of elements.
Great. Let's take one more question from online. This question comes from Anna, and the question is, what about helping students with ADHD or other learning and memory issues? A great one when we think about neuroscience on this one. Andrew, I know one of your latest episodes on your podcast actually dealt with this exact question and how we might think about ADHD and learning. Give us a couple quick tips we can think about.
Yeah, well, first of all, people with ADHD do have the capacity for intense focus for things they really enjoy, which shows that their dopamine system is there. They often, not always, use or need pharmacology in order to access that system for things they don't enjoy. Some of the very behavioral training tools that we talked about today, visual training tools, have been applied to students with ADHD. Oftentimes that it requires a period of movement to I don't have a better word for this, but kind of shake off some of the agitation that's associated with trying to get into a mode of focus when it's challenging, which is one of the hallmarks of ADHD. But then doing a visual focus training exercise, that exercise is a little bit different than the one I described. That one involves visual focus at, say, arm's length out to as many horizons, if you will, over the course of a few minutes. So those are behavioral protocols. And in that episode of the Huberman Lab podcast entitled ADHD, includes a lot of behavioral protocols, also discussions about pharmacology, alternative pharmacology, and also there are now some online learning tools that can enhance focus. Again, the combination of tools is always going to be more powerful, and knowledge of knowledge is great, but implementation of tools is necessary. Just knowing they're out there is not sufficient.
Mr. Eady, you might have an interesting perspective on this one because you get to be on the music side of this, not necessarily, math, science, English. What do you just see on some of this with kids with ADHD or potentially other learning disabilities? And what can we learn from music?
Definitely. The music classroom is a varied classroom. And so there are all sorts of students all working together to achieve a common goal, usually a goal that's bound by time and having responsibility that is unique to you or your section. So one thing I find with students who have ADHD, and I appreciate Dr. Huberman mentioning that freedom for students to, for instance, turn off their camera and our trust that they'll get the work done, letting students know that you're one of the few people playing trumpet. We're going to need you, and we know that you can do it. And giving them the freedom to move around the classroom, do the things that they need to do to be ready to learn. And what that does is it tends to create this community where other students also become aware of what each other need in various ways to be able to work as a team to accomplish the goal.
Great. Maybe we'll try to get one more question. We'll go a little bit more of a lightning round. Is there one more question we want to bring up? So the next one comes from Alexis. So the question is, should you make students explicitly aware of the protocols that you're using? So i.e., I'm in, and maybe we can think about this even in an age group, is I'm with a K through 5, or maybe I'm with a 5 through 8 or 6 through 8. In high school, as you're starting to bring these things in, do you say, okay, we're now going to take a 10-second micro break, or after this, think about an on-sleep deep rest? How do you think about, let's maybe start with the research. Would you talk with kids about that? And then let's maybe go to our in-classroom experts and go, how do you think that would work, and what would you recommend?
Okay, so the great news is that all the research I described involved no disclosure to the subjects about what effects the researchers were trying to obtain. So that's just proof positive that the protocols work to trigger and activate the very sorts of mechanisms that we describe. So in other words, you don't need to know what's happening in order for it to be effective. That said, and here I'm heavily biased because most of my adult life has been spent blabbing to people about the magic of their nervous system and why it's so vital. In addition to talking about the tools gleaned from the nervous system, I do think that understanding a little bit of mechanism gives us all a reference point to lean back to really understand, when I'm doing this, it's because there's a basic mechanism inside me that I'm accessing. I do personally think that's valuable, and I think that students like that, in my experience. And also, you're going to encounter some resistance from time to time, usually from adults, not from kids. That has to do with another phenomenon, which is the age-related resistance to new ideas. That was a joke. But a well-known biological phenomenon. So the idea there is that when you explain to somebody, this is actually how it works, and there's really good research to support this, and none of us is unique. You all have access to this. Unique in the positive sense is you're special. Unique in the general sense is we all have these unique systems that we can apply. And I think people like the idea that they've got these levers and dials that they weren't aware of, and if you start flipping those switches or allowing them to flip those switches, lo and behold, they're learning new things more readily.
And quickly, Mr. Eady, did you talk with your class about what you were doing, that this was the new super protocol? And if yes, how did they react to that knowledge?
Yes and no. Because of time and because of the flow of the class, there's not always the opportunity to go deeply into what specifically is happening, but it's very common in music to discuss the science of acoustics, to discuss physiology, breathing, nutrition. So science is an integral part of good music education. And so there's a time and place to tell students that we actually took this pause for this reason, but you're not going to do that necessarily every time and for every age group.
Makes sense. Well, I think that takes us to almost the end of our 60 minutes. I know I could go on for a lot longer with questions with all of you, so I can't thank each of you enough. Maddie, where you're taking us with technology and your passion and background. Mr. Eady, I think the way you bring it from music and philosophical and some different points of view around performance. Dr. Andrew, can't thank you enough. The research you're doing, I think how you've dedicated your life to providing people these no-cost, low-cost solutions to help live their best lives is such a noble cause. So thank you all so much for being here. Audience, thank you for being here. I know you have classrooms and kids to get back to and teach, so thank you for spending your time with us. We will put as much of this information as we can up on the website for RETHINK. We'll put Dr. Andrews' protocols so that you can put those right into action as soon as you can. And do that. Everyone who is a viewer online, you will get an email that has a link to everything that we discussed today with the different presentations and the different protocols. So again, we can put those into action all up on the RETHINK website.
Yes, and also please participate in our educator survey. It's the same URL as on your screen. And on behalf of Logitech, I'd love to thank our panelists, Dr. Huberman, Ben Edie, El Segundo High School, and all of the educators here live and tuning in remotely. Thank you for joining us.
And we'll see you next time for our RETHINK episode number 3. And please, my last takeaway and plead, I know from all of us with the time, put these into action as soon as you can. Try them. Get back to us. Let us know how it goes. I think as Dr. Andrew said, the super protocol is always in learning itself and always shifting. So thank you. We applaud you for everything that you've done for our children to make our communities and humanity better. Thank you.